How's it going, guys? My name is Angelo, and I'm part of Group 14, which consists of me, Kirby, Christian, Carla, and Huey. And our program is over carbon sequestration. For those of you that don't know what carbon sequestration is, it is essentially the process of capturing CO2 and storing it for long periods of time. The problem we face nowadays is that carbon dioxide is emitted to the air as power plants burn fossil fuels, which is not only bad for us, but is also bad for the environment. Luckily, there are engineers and scientists that has developed a program called CCS, carbon capture and storage, that reduces the amount of CO2 in the air. There are two types of storage. There are two types of storages. There is terrestrial storage, which stores CO2 in no-till farmlands, grasslands, and wetlands restoration. There is the second storage is geological storage, which stores CO2 over 800 meters underground. Now, our program is not going to look at the storages, but it will look at the capture types. There are several capture types out there. The capture types our program is looking at is pre-combustion, oxy-combustion, industrial separation, and post-combustion. Now, our program not only outputs information of those several types, but also outputs information of the several facilities from around the world that utilize these types of capture types. Now, our program will realistically focus on post combustion. So, for example, if there's an engineer that has a system that withstand a certain amount of temperature that would like to know, because how post combustion works is that you need a solvent, you need to regenerate a solvent or you need to use a solvent to capture CO2. And when you use these solvents, you want to regenerate it, which will require energy, which means that there will be heat involved. So the engineer is going to look into this program. They're going to find out which solvent is best for their system that handles whatever temperature their system handles. So I will get to that later in the program. But for right now, let's go ahead and look um, at the algorithm of our program. So we start off with just showing the user the general consensus of carbon emissions per year. And how we did that is we use XLS read to input all of the data that we found online and put it into our program. And then we uh, we did a while loop so that if the user wants to repeat the program, they can. And so we will ask the user to input the years in a range between year 1 and year 2. Now, our program can go from year 1751 all the way to 2014. So the user has a wide selection of years. If the user, however, goes outside of the range, we will output a warning statement and we'll keep asking them until they get the years correct. Now, once they get the years correct, we will output the graph, and the graph will show the data that we found. Excuse me. Now the user can repeat the program to look at different ranges, or they can move on to the second part of the program, which is, like I said, the informational part of it. Now we're going to get into that part right now. So we'll use XLS read to input data that we found online. And let's go ahead and show you that data right here. So like I said, our program will inform the user about the capture types, but also inform them about CO2 capture capacity, um, the, the state or district where that country's facility is from, and just other useful information, interesting information. So once we input that data, we ask the user to select a country that they would like to look at, select the facility that they would like to learn about, and we will output using fprintf, output all of that data onto the program so the user can see the data. Now, another cool thing our program can do is that whatever they see on the program will be saved in a file for them. So if they want to look for later reference, they can. And lastly, we have the post-combustion part, which is the more realistic part the most realistic part in our program, which will ask the user to input the temperature their system can handle. Now, like I said, when there's post combustion, you're gonna need to determine, or depending on how much of, or let's put it this way. If your system can withstand 1000 degrees Kelvin, then you can utilize more solvents than a system that can withstand, let's say, 300 degrees Kelvin. So this program will help the engineer, depending on which system they have, will help them determine what solvents they can use depending on the temperature their system can withstand. So let's go ahead and demonstrate this program to you guys. Let's press run, and now our program is going to ask the user to input years. So we're going to first look at all the years and press enter. Now here is the graph. Like I said, it's going to show the gas emissions, liquids emissions, solids, and gas flaring emissions, and just the total of all of those emissions, and from 1751 all the way till 2014. So if the user exit out the graph, if they want to select a new range, they can. So let's say if they put a range from 1700 till 2014, there's a warning statement. So we're going to have to put a range between those two years, or else the data is not going to, because we don't have that data. So we're going to press enter. From 1900 to 2014, it's going to show the data between 1900 and 2014. So we're going to move on to the next part of our program. And now it's going to ask the user which country they would like to look at. So let's say the user wants to look at the facilities in the United States. We're going to have all of these facilities uh, that our data has, that our data gave to us, and we will allow the user to select which facility they would like to learn about. So let's say the user selects Petronova carbon capture. Once they select that facility, the program will output the information of that facility right here. Now, whatever information you see here, or what the user sees there, the user will have that file saved for them into the program. So in an XLS file. So what you just saw in the fprintf statement is right here in the XLS program. So the user can conveniently save that for later use, for whatever they want to use it for. So if we run it again, they will be able to look at any other facility. So let's go ahead and go to our last part of the program, which is the post-combustion capture part. Now we're gonna press yes, since we want to look at it, and it's going to ask us to input a temperature that our system can handle, from 300 degrees to 1000 degrees Kelvin. So let's say our system can only handle 400 degrees Kelvin. We're going to press enter, and it's going to give us the solvents that our system can handle based on our temperature. So our program will output the solvents right here next to a number, so you can easily find them on the graph. We have number 1, which is mesoporous, and we have number 2, which is mesoporous magnesium oxide. And we have 2 types of graphs, which is pressure and temperature graph, and CO2 capacity versus temperature graph. So the user can have, 2 ideas of what the solvents will look like on a graph. And let's say the engineer or the user, let's say they want to run the program again. Okay. Now, if the user inputs a temperature that is not within our range, we're going to give them 3 attempts to input the correct temperature. If they use up all those attempts, our program will assume 500 degrees Kelvin. And when there's 500 degrees Kelvin, you can see that compared to 400 degrees Kelvin, 500 degrees Kelvin has more solvents. So as the temperature rises, or as the temperature of the system gets bigger, you can withstand more solvents. So if your system can withstand 1,000 degrees Kelvin, let's go ahead and put 1,000 degrees. You're going to be able to utilize all the solvents we have in our data to show to you guys, which is 16 solvents. So it'll also tell the engineer that they can utilize all 16 of these solvents, any of these solvents, because their program can withstand up to 1,000 degrees Kelvin. Now, I want to say one last thing about our program. There is a limitation to it, and the limitation is that our program, just putting aside the fact that it is very informational in the beginning, our program only looks at post-combustion capture types, or post-combustion. And there are several types of capture types to capture carbon emissions, but our program only looks at post-combustion. So if the engineer wants to look at a program about pre-combustion or oxy-combustion, they're going to have to look at somewhere else because this program only focuses on post-combustion. However, it is very informational and at the same time is very useful for an engineer in a real life setting if they want to find out which solvents will be more convenient for them to use based on the temperature their system can withstand. And that's it. Thank you so much for listening, and yeah, thank you.